I'm going to introduce you to one of Splunk's newest products, Data Fabric Search. First, let's set the stage on why we created DFS. You've most likely heard the various V's of big data: volume, variability, variety, and velocity. Organizations are generating massive amounts of data of disparate types, both structured and unstructured. And this data is very diverse in its use and location, and it's being generated at different rates, both streaming and batching. The focus of DFS is to address the first three V's. Historically, data platforms have been built to optimize for one of these at the sacrifice of others. For example, for high volume data analyzed over long time ranges, it may make sense to deploy a large HDFS cluster, Hadoop. For variable data with lots of joins, it might make sense to deploy a large in-memory SQL database. And when there's a variety of data from multiple departments, teams, even organizations, it might make sense to send all the data to a data warehouse or data lake and sort it out later. Imagine the cost of implementing, maintaining, and training engineers on 3 big data solutions, all with their own support contracts. Ideally, there would be one data platform that can optimize for all of these V's without sacrifice. Splunk set out to make this possible, and that's why we've created Data Fabric Search, an advanced analytics solution built for analyzing data at massive scale that optimizes for the type of analysis. You can now perform analysis on high cardinality data over billions of unique values over long periods of time. You can join billions of events from multiple datasets without increasing memory limits. And you can weave together data that lives across multiple remote deployments in an efficient and secure way. It's important to remember that this is all now possible from one platform. Splunk's always been able to digest data from any machine data source. The platform is used for multiple purposes such as IT, security, and business operations. With the addition of Data Fabric Search, organizations can now analyze their data at incredible scale with limitless joins and search the data where it resides using federated search. So how does it work? The typical Splunk components still exist, such as search heads and indexers. The addition of DFS worker nodes allows for search processing loads to be pushed to a compute cluster, so that the processing and memory requirements do not cause a bottleneck at the search head or indexers. If you have multiple Splunk deployments, they can leverage these DFS workers for federated searches across deployments, which is much more efficient and secure. Why is this important? Well, we've seen that departments, even teams, want to share data with each other, but they're weary to do so. For example, the security team knows that they have data that would be valuable to the IT team, but the security team is worried that the IT operations team might access data that they shouldn't. The security team is also concerned that giving the IT team access to their data might lower their search performance. And lastly, the security team doesn't want to manage all of the IT team's knowledge objects. Well, DFS has addressed all of these. What this means is that different departments, teams, and even headquarters can now analyze data across Splunk deployments in a single search. In summary, DFS addresses the volume, variability, and variety of data without sacrifices. Customers are already using it quite successfully. You can go ahead and get started.